Before we start, I would like to acknowledge the traditional owners of the land on which we're meeting today. Today's presentation is another of the Harry Butler in the Wild West lecture series we're running during 2010 in celebration of the International Year of Biodiversity, which some of you may be fully aware of at this stage. This series is presented by WA Museum Scientist and Associate, and we have video podcasts of these lectures available via the museum website, thanks to the generous sponsorship of Chevron. We have the new brochure for the lecture series dates from, it's series 2 from July to November this year, and they're available. There's some on the front desk here if you haven't already got one, so please pick one up. If they run out, we still have more out the front. A few quick housekeeping notes for those of you who aren't familiar with the building. Toilets are just outside the theatre on this side. Emergency exits down the front, and there's one down the back, which we'd probably best not use because, well, unless something happens on the front. But, probably won't need to use it tonight. Unless someone's smoking down the back. We have a mailing list for monthly updates via email. I'm really trying to develop the museum's reach to people who are interested in this kind of topic area directly, which means that we can update you more efficiently, more regularly, and more effectively, depending on what your interests are. So if you haven't already registered your name with us, I've actually got one that I can pass around quietly while we enjoy lectures, so I'll do that. And privacy policies on it, we promise we won't spam you. It's just to keep you aware of what we're doing for adults by the museum. So other things that we've got happening, we still have a couple of lectures in our Day at Pompeii lecture series. There's some fascinating talks, and they're, the ones remaining are covering some of the archaeology and infrastructure in Pompeii, the religion of Pompeii, and the significance of graffiti in Pompeii. So bookings are essential for all of the lectures we're running at the museum at the moment, usually so that we can manage capacity and numbers so that people aren't going to end up disappointed. It's not such a dilemma when we've got a 200-seater like we have tonight, but say at Perth for the lunchtime lectures for biodiversity, there's a capacity of 50, and that regularly hits capacity, so just so that you're aware, that's why we're doing bookings. So on to tonight's content. Our talk tonight's entitled Artificial Reefs, Are They Suitable Habitats for Fish? And it's presented by Sue Morrison, who's Acting Curator of the Fish section of the Aquatic Zoology Department of the museum. Sue Morrison has had an avid interest in marine life since she was a child. She took up scuba diving at university in the UK and later was fortunate to be able to travel to Australia, where she could explore the enticing and warmer waters that we have here. In 1984, the WA Underwater Photographic Society was established, and Sue's been an active member there ever since. She's been employed in the fish section of the Aquatic Zoology Department for over 15 years, initially working as a collection manager, and during the last few years she's been acting curator there. During this time she's been involved in many marine fish surveys from Busselton to the Kimberley region. A major part of her museum work is to document and collect fish species from WA and associated regions. Consequently, areas where the fish fauna is poorly known are targeted for study. The focus on Sue's taxonomic research has been mainly on cryptic and tiny shore eels in the family
Gobiosocidae. Oh, welcome. Thank you for coming along tonight. It's difficult getting here by 6 o'clock on a Friday for those of you that work, so I appreciate you getting here on time. Right, as you can see, tonight I'm talking about artificial reefs and are they suitable habitats for fish. And the main focus for tonight, as you probably have already guessed, is on the HMAS Swan wreck that was sunk as a dive site. And this image here you can see a sort of ghostly form of the bow in the background and a school of globefish in the foreground. So an overview of the talk. I'll be talking about a little bit about the history of the Swan ship itself, the site selection where it was sunk, then on to the methods we use for surveying fish underwater, quite a tricky thing to do, and then we'll go into the results, some of the fish we saw, particularly some of the notable species, and also some talk about the habitat of the fishes that changed as they settled on the Swan, and also the feeding guilds or groups, and a discussion at the end about artificial versus natural reefs, and finishing with a summary. And here you can see a small blenny. It's a little false Tasmanian blenny, a rather cute little character, and they like to live in the sawn-off railings in the superstructure of the ship, so they're quite a popular species there. Now, getting on to the Swan itself, it was hotly contested as a dive site. It was the first naval vessel, or decommissioned naval vessel, that was offered up to be sunk as a dive site in Australia. And various groups, dive groups up and down the coast in WA were saying, please put it in our patch, in our backyard. Anyway, the Geograph Bay Artificial Reef Society, or GBARS, won the bid, and very happy about that. But there's a lot of work to follow after that. This ship itself was commissioned in 1970 as a class destroyer escort, for those of you interested in naval shipping. It was primarily an anti-submarine warship and was fitted with sonar systems, torpedo tubes and a radar computer. It regularly conducted operations up and down the WA coast, but also was deployed in Southeast Asia. The ship is approximately 112 metres long. It's a very long ship, 24 metres tall from the base of the keel to the top of that superstructure, but only 12 metres wide at the widest point amidships, quite a skinny ship. The hull is actually made of steel and the superstructure is aluminium. And at the time it was sunk, it was the largest ship in the southern hemisphere, intentionally scuttled for diving purposes. So quite an exciting venture. And I will stay on this slide for a bit, not too long, but the rationale for the survey. The Sea Dumping Act in Australia is very strict, and the Department of Environment, Water, Heritage and the Arts decreed that it must be demonstrated that the surrounding environment wasn't degraded by sinking this, and that there were no contaminants or anything coming out of the ship, whether organic or chemical. So naturally we had to inspect the hull for pests, introduce things such as worms, barnacles, molluscs particularly like to grow on hulls of ships. So if any were found, they had to be removed as best could be. And a baseline study of the site where it was going to be sunk had to be done to see what was there beforehand and see if anything was going to be impacted upon badly. And as you can imagine, it took an awful long time to prepare this ship for scuttling. It took a whole year. So Jeff Painter from Bunbury headed up GBARS, and he was in charge of overseeing this. And the Navy obviously stripped the ship as best they could. And then there were things like doors, loose fittings, basins, lids and things that had to be removed, things that could float off and get in the way of people. Areas that divers could get into and get stuck, engine rooms and things, they had to actually seal off. And of course there was quite a lot of oil and fuel deposits in the engine room. In fact, it was filthy. And that took an awful lot to clean that out. So it took a whole year of GBARS with many volunteers, and I expect some of you in the audience were volunteers. I was one of them too. And just before it was sunk to the dive site, the hull had to be scrubbed manually on the outside by a very keen team of scuba divers. It was then towed to the site on, I think it was the day before, so the 13th of December, they towed it out there. And as you can see in the bottom picture, if you look carefully, there are holes cut in the side here. These are access holes for divers to make it a little bit safer and easier to dive on the ship. And there were also other areas that were partly cut through but weren't pushed out. And these were carefully planned, so explosives were put in the ship, and when the explosives went off, these would get blown out. And obviously if they were put in too near the waterline, at this stage it would have sunk before it was meant to, and they couldn't tow it to the dive site. So on the day, explosives expert from Canada, he makes a wonderful career out of this job, he set all the explosives and checked everything very carefully. Now the bow had to go down first, so a sequential series of explosions from the bow to the stern. So the idea was they wanted it to sit upright on the seabed, so the bow went down first, sort of stuck into the seabed, hold it steady, and then the stern would gradually settle down, it would sit nicely upright. And it all went according to plan. That's wonderful. The black smoke and the fire was all really fireworks. That wasn't really the explosives. They had to make it look good for all the visitors and many boats. And the white smoke might be a little bit to do with the explosives. And up here, that's just the back of the stern. And there was an awful moment where it sort of lurched to one side. Thought, oh no, it's going to lie on its side. Disaster. But it didn't. It sort of came back. And there's a slight list to port. But they did extremely well. And the site had to be selected carefully, of course. It had to be reasonably flat for the ship to sit on it. And it had to be deep enough, 31 metres. Bare, flat sand. Well, there's a few little lumps. Oh, sorry. Lumps of reef. These are nothing more than about 1 metre high, and they weren't really a problem. But apologies for some of these images, the grungy ones are mine. There's a lot of backscatter here because there's quite a bit of salt stirred up. And, but most of the seabed is sandy and flat. And it's a very well protected site. It's inside Cape Naturalist, as we shall see here. So there's the Swan site, sinking site, and it's just off 2.4 kilometres off Point PK, the closest landmark, and probably you'll know better Meelup Beach, which is just down from there. That little curve there, I think, is Meelup. So it's protected from the prevailing southwesterly winds and swells that come in this way. Winter, we do get some northerly winds, but it's in deep enough water, they don't seem to really disturb it. We're very worried the first winter it might move around, but it didn't move at all, as far as we know. And also, the monitoring that had to be carried out, was decreed by Juha, had to be carried out for 5 years after the ship was sunk. So the first 2 years are three surveys a year, and the last 3 years just 1 a year. So a team of, I think about 6 of us volunteered to do this, and it was actually great fun. And so the monitoring was to actually monitor beneficial effects, or the marine life settling on the vessel, and anything that might be detrimental as well. And they actually did do some sediment sampling for hydrocarbons and any heavy metals, but there really wasn't an issue. And in fact, they've done more sampling of the sediment, a more intensive program with the Perth that's down in the Albany, King George Sound. And they found tiny traces of TBT, which will have come from the anti-fouling, but they think that just fell off when the ship was being sunk, and it really hasn't spread any distance from the hull itself. So that's not a problem. And the wreck stability is not part of our study, but the Conservation Department at the museum have been studying the metals and how they corrode over time. Right. And also in this image, you can see where some of the other sites are that we looked at. So we had to have a control site to compare our surveys on the Swan. So the reference site is flat sand, really flat sand with nothing there. Not very exciting, so have to lay out a line over the flat sand. Natural reef we looked at right bank, right off Cape Naturalist, quite an exposed reef with oceanic waters, and a difficult one to dive because often affected by the swells there. And Geograph Ridge, or sometimes called the Old Shoreline, that's about 18 metres depth. Oh, right bank was 18 metres at the top. Geograph Ridge is 18 metres, but only a 2 metre profile, and then it's flat on each side. It's quite a strange site, but the marine life does tend to congregate around that ridge. And another artificial reef, Busselton Jetty, and that's almost 2 kilometre long wooden, well, it was a wooden jetty, now being refurbished with concrete and things, and the deepest spot on that one is only 9 metres. So some different sites to compare with the Swan site. Right, the methods we used. So it's quite a well-established method for fish surveys, is a diver who has to know their fish quite well, swims along a set length of distance on the bottom, and you have a clipboard in front of you with some waterproof paper and a pencil, and usually a checklist of things you expect to find, because it takes a while to write underwater and you can never read what you've written when you've come up again. So, and for this particular job, we did a 100-metre long transect and a 5-metre wide belt, so 2.5 metres each side of where you're swimming. And you have to go along fairly slowly, but not too slowly, otherwise the fish you just counted will swim in front of you. Very familiar group. I just counted 20 of those. And so you sometimes have to just keep in your mind what you've counted. You know, there's a school with a jewfish hiding in the middle. I thought, yes, I've done that one. But occasionally we'll get a few repeats and errors, and you can never be absolutely perfect. And being in temperate waters, the fish numbers aren't too immense except for 1 or 2 species. So you can actually count or estimate absolute numbers. So that's quite good. What we did was 2 transects. So we had 2 fish surveyors per dive. One would go down the port side and one would go down the starboard side. So much for the buddy system. One on each side of the ship, and we'd swim along the seabed for 100 metres and count everything within a 5-metre band. And then you'd come up a few metres, swim along the middle of the hull, back to the front again, and up again, and one last 100 metres, so 300 metres virtually, along the superstructure for each dive. And then the next day, we'd do the same thing, but we'd swap sides. And the interesting thing is we compared our estimates, like some of the really abundant fish, and we were pretty close, so we were quite happy that our method was working well. So we used the same observers for consistency. And it's a great method because you're not killing fish, only visual, it's quantifiable, you can repeat it, and it was long-term, over 5 years. And here we are, that's me on the left with a sheet, and that's Glenn, one of the fish observers on the right, on a reef. Actually, it is a tropical reef, not a temperate one, but it's the only picture I had of him. So you can't look down too long because you'll miss fish, so you have to quickly write your numbers down, look around, look down, and also look out into the water a bit, not just right in front of you, so you've got to have a very flexible neck. Now, when the ship first went down, it was very clean. But this, so on the right is a fantastic picture that's quite well known by Jeff Painter. I think that was the day after it went down. Quite clear water, which it hasn't been since, and the superstructure at the top of the mast on the left. That only lasted a few days, actually, a few weeks. On the left there is the magazine rack. All the ammunition was kept with a diver. A bit gloomy in there, but a wonderful little habitat for lots of invertebrates and fish to go, lots of holes to hide in. And on the right is the, I suppose it used to be called the fluffy duck, I think, the black swan. But he's long grown over. They used to try and keep it clean, that bit, but he's long gone now, covered in marine growth. So within the first few weeks, little invertebrates started appearing on the hull. And the most prolific ones are these funny little spidery growths, and they're actually hydroids, related to corals. They're tiny little polyps. You can't see them on that one because it's so small. So these spidery ones, and then the lovely pink ones, the top right here, another form of hydroid. These funny little pale anemones were everywhere, quite a bubbly sort of looking stem and very pale tentacles. And a bit later on, we got onto some nice soft corals appearing, and there you can actually see the polyps there. It's a soft coral because it's got little 8 tentacles. And gradually, in the ensuing weeks, so the first month actually, a month to 6 months, we got this, like an organic crust, I think we call it, of organic growth, and you can't see any paint here. The dark stuff is algae, the pale blue is a sea squirt, and here you can see it slightly magnified. And lots of sea squirts. The yellow is a sponge, big monster sea squirt there with 2 siphons, and a compound one there. And a bit later on you can see this is superstructure, not clean at all anymore. White fluffy soft corals, sponges, ascidians, and lots of little nooks and crannies for other things to start living in. And the interesting thing, as I said, it had a slight list to port. Now, it faces northwest, the bows in the northwest, stern in the southeast, and a slight list to port. So the port side, over on the left, is shaded from sunlight most of the time. So not much algae grows on there, because that needs sunlight. And that's really good for the invertebrates, because they can thrive, and the fish live amongst it. And you can see, again, the white soft corals, yellow sponges, all sorts of other things coming along there. And on the right, a bit murky I know, but on the starboard side and the superstructure, lots of sunlight. So there's algae galore, particularly in the middle of summer. This wispy stuff, but it's good for different animals. So you've got a nice range of habitats. You've got algae and invertebrates. So nice diversity there. Now, overnight, as friends dived it the day after it had been sunk, overnight, these bullseyes moved in. I couldn't believe it. But fish range around quite a lot, obviously, and these bullseyes are, during the day, they tend to shelter in caves and ledges, and at night they come out to forage on plankton, the plankton feeders. And hundreds have moved in, so imagine every night they must go out looking and, hey, there's a nice new place to live, let's move in there. That was quite interesting. So even today, there's lots of them there, but their numbers just rocketed up, as we shall see shortly. If you looked into one of the holes cut in the side, that was all you'd see, solid fish. And here are some of the other early settlers. This is the bow of the ship here, and these are tarwine, and one little jewfish, young jewfish hiding in there, trying to not look too obvious. And here is Sergeant Baker sitting on the steps, and some long-finned sea pike look like they're learning to read. Now, onto the scientific side of it. Have to bear with me for a little while we go through this. So this is what we did. The top graph, abundance, so that's the absolute numbers of fish we counted. Obviously, with the bullseyes, we had to do an estimate, but we reckoned they weren't too bad. So along the bottom of the graph, abundance graph, we've got all the survey dates. So from 97 up to 2002, the 5 years. So you can see there were more surveys during the first 2 years and then just once a year for the last 3. So the blue line is our control or reference site on the bare sand, and the red line is the Swan wreck. So it's the mean number of fishes we counted per transect. So for each trip, there were 4 transects, 2 on one day, 2 on the second day. So it's the mean number. As you can see, the numbers just shot up. That's the baseline before the ship went down. That's the first survey. That was about 3 months later. So in the first 18 months, it just went mad. And we'll see later on what that's caused by. Then it dropped off quite dramatically and fluctuated around and kind of levelled off to a bit of an equilibrium. Sadly, we didn't have the opportunity to sample during the year here. I mean, there could have been some peaks or troughs, we don't know. Could be seasonal changes there. But we just have to live with what we've got. And so the maximum number at that peak was 2,400 fishes. And at the reference site, the maximum, well, actually, it was 10. Well, it says 25 there, but I think that was a total something else. And down the bottom slide, we have a number of different species, not individuals, but number of species. So it's the mean number of species for transects. So again, the same colour coding. We've got blue for the control site, red for the swan, and you can see just gradually the average number, certainly from the baseline, it shot up, of course, but it's gradually increased, particularly in the first 2 years, and then it's sort of levelled off a little bit. But still, you often see the odd new species, and that's quite exciting to see. And the control site, we have a little blip here. That might have been when the Lewin current brought down a few extra species from up north, a few tropical species, but as I say, the numbers are very low there. So what is the composition of these fish communities? So at the end of 5 years, the final survey, we had 10 species that made up 86% of the abundance. And again, there's tarwine and the rough bullseyes that you've seen, and they're about over 50% of those 2 species. And then we get to the footballer sweep, globefish, which you've seen, and I'll show you 1 or 2 of the others later on. But the other is really only four species that make up a large percent of the abundance. So here we have the tarwine. It's closely related to the pink snapper, and quite a pretty fish, stripes on it. These are all under the stern. They love hanging around any sort of little hollow or something. Again, as you often see jewfish hiding in amongst all the others. Don't want to be seen. But they also occur at all depths and right down the seabed where they are here, midships, right up to the superstructure. So they seem to like all sorts of habitats. And the globefish, they're very cute when they're little. There's this little one, but as they get older, they get quite ugly, in fact. So they're, but an interesting fish because on the natural reefs, you only ever see small groups of them, particularly when they're juveniles, maybe 10 or 20. But here, this school seems to hang around all the time, and we've counted 250 to 300 individuals. It's immense. And Barry Hutchins, who used to be a curator at the museum in Fish, he said, no, they don't school. No, he wouldn't believe me. And I'd show him some pictures. He said, no, picture's not good enough. Can't convince me. So finally, we got him diving down there, and he said, oh, well, maybe. I've never seen them school like that anywhere else. So they're usually at the bow of the ship, sometimes at the stern, sometimes at the side, but they've been there, gradually building their school over 5 years. Interesting. Western king wrasse, ubiquitous species everywhere. That's a male. The females are paler with a red stripe, and they tend to act as cleaner fish or a lot of other fishes, omnivores. Our little footballer sweep, sorry, that's the best picture I could find, that little fellow, stripy one, very abundant, usually sort of higher up in the superstructure. And these gorgeous batfish, which are one of the favourites of many divers. They're bigger than a dinner plate, some of them, about this big, and they love schooling around the top of the ship. And we've counted up to 25, 30 of these big fish, and they're quite curious of divers too. But they're a tropical species, probably come down in the Lewin Current again, and I don't think they actually breed down there, but they're actually found as far south as Albany, and they hang around the Perth wreck as well. So they like these deep pinnacle-type structures. And on to a little bit more, examining exactly what's happening with these 10 species that are most abundant. You can see these rough bullseye in the blue line, sorry. So again, survey dates along the bottom and abundance up the side. So the blue line is these bullseyes, the largies, have been causing all these strange patterns. And their numbers shot up. So I said they moved in overnight the first day, and they obviously like the hollows in the ship, inside the ship, to inhabit. Plenty of food. They're planktivores, so food's available, good currents coming past the fish with their food. And they, I think they probably breed quite well there as well, and a good refuge from some of the predators. Same goes for in the red line, that's the silver trevally. I didn't actually show you a picture of one of those. Little silver trevally there. Have some little peaks here in the first and the second year. The green line is the tarwine. That wasn't quite as dramatic, but had a little increase here, and then sort of seems to be the most abundant one by the end of 5 years. And in the pink, we have the black-headed pullers, which I'll tell you, a little damselfish I'll tell you a bit more about in a minute. So what we think is happening, or what we have seen happening, with these sort of really rapid decreases in population, is that the predators, of course, have moved in. Oh, what a great place to go and feed. So we have the Sampson fish, and again, I usually just see one or two, and there's quite a large number of them. And I saw one swimming along with the silver trevally sticking out both sides of its mouth, so evidence there. And a close cousin, the yellowtail kingfish. They're often seen around the top. The others were, well, they go all levels, but yeah, and not such a good shot. But this is the mulloway, and they're such shiny, silvery scales. It's really hard to get a good picture of them because it all reflects. But these would love to hang around the stern, right under where the prop shaft is, and they're ones responsible for making grunting noises you sometimes hear underwater, especially if you dive in the Swan River at night. Quite an audible sound. And they eat small fishes too. So some nice big predators hanging around. And so I suppose it's just a natural succession as some move in, other ones think, oh, I'm going to feed on those or find another little refuge to live in. So it takes a while for the equilibrium to settle down as all these different fishes happen upon the wreck. Bit of a picture of what was happening over the 5 years. Again, survey dates along the bottom, number of species observed. So this is the numbers from each survey in the blue. So total number per survey, and that's increased up to 47. And then this is the cumulative number in the purple. So we've added the ones from the survey before. So it means we're seeing new species, a few new ones each time that we go. and I'm sure we'd see a few new ones even if we went today. So that's quite exciting too. It's 92 different species that we saw over the 5 years. There were 1 or 2 species we saw, but they were outside the transect line, so we couldn't count them, which is always frustrating. Like big rays, smooth stingrays, wobbegongs. Oh, too far away, come in. And it is exciting to see some of the more territorial fishes, the ones that we potentially threatened. One of my favourite species is the western blue groper, and they can grow huge. They're one of the biggest bony fish in WA. And that's the male on the left, or he's just turning into a male. The younger ones, or the greenish ones, are females, juveniles, and that one on the right is actually inside the vessel. You don't see so many fish inside. And the male on top. And these are just a little quick aside here. They have an interesting life history, these wrasses. Quite a lot of wrasses do this. They change sex. They start off life having both male and female body parts. As juvenile, they're not mature, they can't breed. But as they grow up, they turn to female. But they have a little family group, and the largest one in the group is a male. So the female actually turns into the male. So he can be a bright blue by the time he's really mature. So he has a harem of a few females, but if something happens to him, he dies or something gets fished out or something, the largest female, within a matter of a few weeks, turns into a male and takes over his role. So they haven't lost any breeding time. Very useful little strategy there. Another interesting territorial one is the yellow-spotted boarfish. That's just a juvenile there, looking very worried. He's right under the hull there. And I suspect some of these get fished out. We sadly see little recreational fishing boats coming over the wreck. They're not meant to fish there. Those fish stay around the same spot, and you come back the next day and they're gone. You think, something odd going on. But fortunately, a few more recruit, and we do see them from time to time. And on the right is our pink snapper, hiding in a school of globefish. A lot of the fish like to hide amongst them. Maybe they've got all their spines. I think it's a safe place. Western Stingaree, that's just only found in WA. A lovely little stingray. King George whiting, again, another recreational, popular eating fish, unfortunately. That's the trouble, it attracts the fishermen. White-lipped catfish, they tend to be nocturnal, so we do actually find a few of these inside the vessel, but he was just rummaging along in the dark shadow at the base of the hull. And the southern blue-spotted flathead, another good eating fish. Now, what's happening with these groups over time as the wreck was settled? So the first, again, time along the bottom, and percentage of fish abundance up the side, or proportion. Before the wreck was sunk, all the fish that we recorded, which wasn't many, were ones that live in weed and sand, which isn't surprising, because that was basically all that was there. But the first survey, 3 months later, after the wreck was down, all the carnivores that had moved in. You see the pink? So over 50% carnivores, and also some pelagic open water feeders have come in as well. And you can see over the 5 years that these proportions are varied, and it may be seasonal effects, food availability in the current, like see planktivores and whatever, or pelagic fish have increased here. Maybe some have come down with the Lewin current. Don't quite know what's happening. And it fluctuates around, and that was after the end of 5 years. So again, we'd like to look at that today. And then to see what sort of diets the fish have. So the weedy, sandy ones that were there before the ship went down, most of them are omnivores, which means they eat everything. A bit of algae, a few little, maybe invertebrates, maybe a few small fish, depending on the size of the animal, what they feed on, and a small proportion of carnivores, not so many. But as soon as the ship went down, planktivores galore. Well, bullseyes are one of those, so that would account for a large proportion there. But that, as you can see, that's again fluctuated around and settled down a bit, and the proportion of omnivores has come up a little bit there. But carnivores certainly seem to be the dominant group now, which we can see quite easily. Now, how did we compare our artificial swan wreck reef with natural reefs and the Boston Jetty? Well, we've got a statistical program, multidimensional scaling, and what it does, it just looks at all the fish species that you've recorded and the numbers of species you've recorded and compares them all. Very clever. And so it, the closer the marks are on this layout, the more similar they are. So over on the right-hand side in this circle, we've got all the control sites in green, so survey 7, survey 10 is just the survey number. And B, there's one swan one, well, that's the baseline one before the swan went down, so it was just flat sand. So not surprisingly, they're not tightly clustered together, partly because we're counting very low numbers of fish, so even a change in one species could make them far apart. But they're definitely separated, well separated from all the reefs that we looked at, natural and artificial. So in blue, we've got all the swan surveys, and they tightly scrunched together, so pretty similar. There's a couple of different ones, survey 1, survey 2, and that was where fish were just coming in. So again, you can understand why they're a little bit different. The red is the Boston Jetty, and they cluster nicely, tightly together. Sort of reasonably close to the swan. But also close is Geograph Ridge. There's only 2 surveys we did there in the purple. Again, it's in a fairly similar habitat to the Boston Jetty, not far away. So you'd expect to have species in common between those different sites. And in the pale blue turquoise is the right bank reef. And that is, as I say, quite a different reef. It's more oceanic influence there out on the edge of Cape Naturalist, and more influenced by currents out there. A few different species. The habitats are fairly different with, it's a basalt rock instead of limestone, and the kelp growing on it, the algae are slightly different, slightly more dense stands of algae. So they share quite a few species between them, but there are distinct differences, so that settled out quite nicely. So here's a couple of views of the different places. I'm sure many of you will have dived Boston Jetty, fabulous site. And this is looking up Yellowtail scad, huge schools, and that's the top of the jetty through the water. And these are the jetty piles, which you can barely see for the fish. And nowadays you can virtually swim right through them. They'll come right up to you because fishing hasn't been allowed at the very far end. And this is one of the jetty piles with some old wives. And again, here's a jewfish hiding, pretending stripes go the other way, but I'm an old wife. And Geograph Ridge, I say that's just the 2-metre high old shoreline, but an astounding number of fishes and other marine life inhabits that spot. It's got seagrass in some areas, it's the old wives again. It has huge patches of this beautiful cool water coral, a turbinaria coral, it's a hard coral, and lots of little places for the fish to hide. Again, the bullseyes are there everywhere. Whereas right bank, as I said, it's not a great shot of it, but lots of kelp and other algae, so a fairly different habitat there. That's a spiny-tailed leatherjacket. Nice spines on his tail. And that's a blue devil that you find in actually Geograph Ridge as well. And now onto the actual maturation, I suppose you'd call it, of the Swan artificial reef. The exciting thing we found here was that some fish were breeding on the wreck. So here are these little blackhead pullers, and this one here is the female laying the eggs, and then the male will come over afterwards and fertilise them. And they do a little dance. They have a courtship beforehand, clear a nice little spot on the deck free of debris, and lay their eggs, which actually stick onto the substrate, and then the male guards them afterwards. He keeps debris away with his fins and takes away dead eggs and anything that might affect the good healthy ones. And then once they hatch, they actually go off into the plankton for probably 20 to 30 days for this genus of fish, and so that's good for dispersal. The little larvae can spread quite a long way in the currents and the plankton and settle out after 2 or 3 weeks and find a new home to live, but I hope some of them managed to stay on the Swan to repopulate, and I'm sure they did, because in this picture down below, these are actually lots of juveniles we saw actually on the wreck itself. So that was very exciting to see. And another one that is possibly breeding on there is that little blenny that we saw at the beginning with the little horns. They have a similar strategy in that they lay their eggs, their adhesive eggs, on the substrate. But their little larvae don't actually, well, they don't actually have larvae. They have the eggs hatch and they develop directly into small fish. They don't go off into the plankton. So imagine that little blenny who's only from 10 to 15 centimetres long had to swim a long way to reach the swan from the nearby reef and settle in there. A whole group of them did. And then lay their eggs. So obviously the young don't spread very far, very quickly. It would take a long time. And what else? We have the batfish, but I don't think they're actually breeding on the wreck itself. And which other one? Here we go. The rough bullseyes, yes. They have planktonic eggs and larvae too, so they can disperse quite widely, and they obviously have done because they're on all the surrounding reefs as well as on the Swan. So a bit of a population explosion for them. So the variables that affect artificial reefs, you can see that the Swan is a pretty successful artificial reef. There's a good number of species. So we counted a total of 92 species by the end of 5 years, and there were obviously a few more that we couldn't count. In comparison, the Bustleton Jetty, in 9 metres of water, we counted a maximum of 59 species. Right Bank, 34 species, and Geograph Ridge, 30 species. That was the total number. If you take a mean per survey, you still find that the Swan comes out on top in diversity, a mean of 47 species, as opposed to 34, 20, 23, and the control site was just 5. So it's certainly been a good place for recruiting fishes, and it looks like they're actually staying there as well. They aren't just appearing, being counted and swimming on around the corner. So that's quite exciting to see. And the things that make an artificial reef successful or not is in the planning. You can't just go and dump some old car body or something in off the shoreline near where you live, because the waves are going to affect it. There could be contaminants. It has to be cleaned, of course. So the things that you have to consider are the horizontal spread of your reef. The longer your artificial reef is, obviously, there's more places for fish to live. The vertical spread, the Swan is fantastic because it's from 8 metres below the surface down to 31, so that's a nice depth strategy. So you've got the ones, the pelagic fishes can hang around the top, mid-water fishes in the middle, and the benthic ones along the seabed, right near the hull. That's a good place to look. The complexity of the physical structure. So more nooks and crannies, obviously there are more places for all the fish to come and live, and for invertebrates to live, and food, of course. So increased complexity, increased number of species. Light is another. There's lots of physical factors to consider, like light. As you saw on the port side, very little algae growing, invertebrates could grow. Light on the other areas, superstructure and starboard, lots of algae grows, so fish that like eating algae, or little animals that live in amongst it, that's good for them. Currents obviously have big impact too. It tends to be the cool water currents bring in more plankton for fish to feed on. So the tropical currents aren't actually, tropical waters aren't always so rich in food, which is surprising. Sometimes they get upwellings from deep areas, but our cool water, cold upwellings are full of food. So it's not a bad spot. There are some decent currents that whip around Cape Naturalist, and we get some tongues coming into Geograph Bay from the Lewin current as it comes south, so you get some nice mixing. And of course seasonal changes. You're going to get, every year could be different. Like on the land, sometimes we get lots of rain, sometimes we don't. Sometimes the currents whip past, sometimes they don't. Sometimes the wind is strong, get some terrible winter storms and might do a bit of damage. So these can all affect fish recruitment and survival through the year. And of course food availability, whether it's in the plankton or whether they feed on other fish or invertebrates or algae. So if these things are all taken into consideration, you can get a fantastic artificial reef. And I certainly think the Swan wreck is a very successful one. And it has followed a typical pattern of settlement on a reef, but no quantitative survey of a naval vessel anyway, or a boat, has been done from scratch before, so it is quite an important study here. Other artificial reefs include old tyres as a popular one, but they don't really have much profile, and they do break down and fall apart. Concrete slabs, again, they can break down. Anything that's man-made is considered an artificial reef. It could be a groin. Some of these are really interesting places. Jetties are fantastic usually. Lots of things to find under there, but I think this vessel has been a very successful one because it's in a good depth of water, and it's got complexity, good length, and all the rest of it. So, summary. So, prior to the scuttling, the Swan site had a similar fish community to that control site. Surprise, surprise. A total of 92 fish species were recorded on the vessel during the 5 years of monitoring, but there'll be more by now. And the abundance was over 27 times out of the control site after the 5 years. Approximately 86% of the fish abundance on the Swan is represented by 10 species, and the tarwine and rough bullseye are over 53% of that. So they're a big group. And the fish community of the Swan has rapidly shifted from the omnivorous, eating everything fish that live on weed and sand, to one dominated by planktivores and carnivores, and a few pelagics in there. And the species richness and abundance on the Swan is beginning to approximate that of other natural reefs in the region. However, the species composition is distinctly different, and it'll probably always remain so, because each location is slightly different in all those physical factors I was talking about. And recruitment has been confirmed with the blackhead pullers mating and laying eggs. So it's very exciting. So, my conclusion, artificial reefs of suitable material in the right location can enhance fish habitats. And the survey team consisted of Peter Morrison, my husband, Glenn Moore, the other fish person, Jenny, Al, Stefan Eberhard, Melissa Titilius and Matt Jury surveyed the invertebrates on the Swan, which I didn't talk about tonight. They actually did video transects. So we were a very busy team. And Cape Dive, Shelley Blythe was just magnificent. She gave us lots of sponsorship. She was really supportive. Jeff Painter from Geograph Bay Artificial Reef Society was wonderful too, and Barry Hutchins from the WA Museum. And I have to give credit to Jeff and Jenny for some of the images tonight. That's one of Jeff's there. All the clear ones are Jeff's. And thank them very much.